So the lesson objective is I can determine different functions' inputs and outputs. So here we're going to fill in the table of values for f of x equals the square root of 9 minus x squared, and then we're going to sketch the graph. So how do we plug in these points? The way this works is we're going to take this value and plug it in for x. So we get the square root of 9 minus negative 3.5 squared. So that's going to be the square root of 9 minus 12.25. So now that we have the square root of negative 3.5, this is going to be an error because we can't take the square root of negative numbers. Now we're going to do the same thing. So why don't you go ahead and do this for the negative 3.5, negative 1, 0, 1, and 2. F of negative 3 is going to be 0. We plug in negative 3, get square root of 9 minus negative 3 squared, which is 9 minus 9. Square root of 0 is 0. F of negative 1 is going to be square root of 9 minus negative 1 squared. That's going to be square root of 8, which is about 2.828. Then we're going to do f of 0, which is going to actually just be square root of 9, which is 3. And then we can do f of 1. F of 1 is also going to be square root of 8, which is approximately the 2.828. And then we do f of 2, and that's square root of 5. And that's about 2.236. And then we can do the last value, which is f of 7. So we get square root of 9 minus 7 squared, which is 9 minus 49. And that's going to be square root of negative 40, which is also an error. So we can go ahead and fill out our table. Then we're going to go ahead and graph. So at negative 3, we're going to be at 0. And then at negative 1, we're going to be between 2 and 3. At 0, we're going to be at 3. Oh, I have this wrong. All right. Then at 0, we're at 3. And then at 1, we're going to be right here again. And then at 2, we're going to be here. And then at 7, it doesn't really exist. But so our graph looks like this. So it says which x values do not have an associated output. So those are the values. That are either greater than 3 or less than negative 3. So those were negative 3.5 and 7. And the reason is these give the square root of a negative number. And the square root of a negative is undefined. And then which values of x have an output? That's from negative 3 to 3, including them too. What is the highest y value that is reached by the graph? So the highest y value is 3, the lowest is 0. And these are the y values, so it's talking about, the y-axis. I hate when that happens. Okay. So this is the lowest. And this is the highest. All right, the graph of g of x is 1 over x minus 4. And it's shown right here. And this person plugs in x equals 4 into the graph. And the calculator says error. Why is this? Well, let's plug it in and see. So we get 1 over 4 minus 4, which is 1 over 0. And that's undefined. So when we look at the domain of g of x will be all real numbers. This means all real numbers except for, and you could also say all real numbers and then do like a /4 to mean like you're not including 4. And then the range, so this is domain, the range would be all real numbers except 0. Because it doesn't go past 0. It never goes past the x-axis, so it never actually is 0. Now, without graphing, this question asks us, can we explain what the domain is of our graph? So remember, this denominator cannot be 0. So we do 5x minus 3 equals 0, and then we solve for x. And we get x is 3/5. So the domain is going to be all real numbers minus 3/5. And just some quick notes. So the domain of a function is the set of all possible inputs that produce a defined output. Values that produce undefined outputs, like the square root of a negative number and a number over 0, must be restricted. And then the range is the set of all outputs. So after watching this lesson, you can define the domain and range of a function.